Take a look at our first example of nonlinear expression graphs. And this is still Passport to Advanced Mathematics. And we are looking at area 13, which is nonlinear expression graphs. As we have seen in different formats, you may have uh, linear expression graph. Generally, linear expression follow the equation y is equal to mx plus b. And you know, when you draw this kind of stuff, you get equation like that, maybe like that. These are linear equation. Now, when it is nonlinear, generally it is curved. Nonlinear equations, for instance, this is a quadratic equation. Nonlinear equation follow different system. It depends on the kind of nonlinear model you are dealing with. Most nonlinear model that you probably see will be a to the power a times b to the power x. And generally, these models behave like this, either like this, or they behave like that, or behave like depending on what the x variable is, whether it is a negative x or positive x. So now this question here is looking at some living organism in a lake, and they want to determine the growth pattern. In essence, they've given you the simple fact that it doubles every year. So each year, as you can say, if the biomass right here, if the biomass in a lake doubles each year, which of the following graphs could be used to model the growth. So as you can tell, this is a growth. Now, clearly you see that this is a linear model. This here is y is equal to mx, right? Because your b is the y-intercept is 0. So here, this means the growth is constant every single year. But this says it doubles. So obviously this cannot be your answer. If you look at the b part here, you can tell that it grows and then it stop growth. It grows like this, and then here the growth is constant for a whole period of time, and then it changes growth a little more. It's constant a whole period of time. It grows a little more, and it does that. So here, this obviously is not uh, a growth that doubles. So this obviously is also wrong. Now let's take a look at this. If you look at nonlinear graphs, y is equal to 2 to the power x, represent doubling every year. Y is equal to 3 to the power x, represent tripling every year. Y is equal to 4 to the power x, means it quadruples every year. So these should be some of the things you should be familiar with. So these kind of graphs generally behave like this. And if you want, you can plug in number 1. When x equal to 0, y is equal to, for instance, 1, which is here. When y is equal to 1, x is equal to 1, 2 becomes 2. So it goes gradually, you see. So this graph represent these kind of models. I want you to be familiar with them like this. And so obviously this is going to be your answer. But let's take a look at this. Whenever you have equation like this means y is equal to a constant k. That means y doesn't depend on time because it's a constant. So in this case, if you look at this carefully here, y is equal to 1.5. That means it doesn't matter what time does, y will never change. When x is equal to 0, y is equal to 1.5. I'm sorry, when time is equal to 0, y is equal to 1.5. When time is equal to 2, y is equal to 1.5, which is the biomass. So this is how you analyze this kind of problem. So obviously your answer is choice C.